system, rebellion of machines will not happen. The other day, SkyWay Information Service talked to a specialist of the SkyWay design organization in the field of artificial intelligence and automated control systems, candidate of technical sciences Sorokin Yuri Adamovich. Why do we need intelligent systems? The development of artificial intelligence is now at early stage. When man decided to train a machine to analyze information and make decisions, he began by adding certain algorithms into it. The result depended on the ability to foresee everything. It was obviously impossible. Therefore, there arose the need to teach the computer to think, to reason, to be able to adapt. Professionals all over the world are now trying to implement it, but still, computer cannot do without a human. In what does artificial intelligence look like a child? Somewhere in the ideal universe, children can learn from their mistakes. They explore the world themselves, and the cost of their mistakes is incommensurably small. However, it isn't a perfect universe. And in the real world, you wouldn't want your son to stick his fingers in a socket and find out that electricity hurts painfully. The same situation is with artificial intelligence. For example, there is a small car, there is a labyrinth. A small car is started up there, and that it would look like the exit. The car drove into a dead end, remembered that there was no exit, and returned back. The cost of such an error is small, the risk is appropriate. But suppose an obstacle appears before the car in the process of movement. For example, a truck standing on the roadway, braking distance to which is not enough. The car, tuned to strict compliance with the traffic rules, will face a challenge to cross full line and go out to a free lane of oncoming traffic, or slow down and allow a collision with possible consequences for passengers' health. Self-learning car can make a choice not to violate traffic rules, and then, according to the results of consequences evaluation, it will conclude that the decision was wrong. But you would hardly like to become a laboratory guinea pig to train a car at the expense of your health. Therefore, self-learning for artificial intelligence is only possible when the consequences of making a wrong decision are small. Accordingly, the role of man in the construction of systems with artificial intelligence is undeniably high. Initially, it is he who should teach this system. And the quality of training will depend directly on the skill of developers, programmers, on everyone who teaches it. The car must be under control at all times. How do we teach SkyWay transport? Let's take, for example, the facial recognition system installed in SkyWay transport complex. In order for it to learn how to detect cases of health deterioration, acts of vandalism or violence, unwanted passengers, it had to learn to recognize faces initially in principle. It was offered a huge number of images of people and situations, including illegal ones. The system identified certain patterns in this way to eventually identify people to ensure access control to the services of the transport complex and detect situations with forgotten things or fights. Training of train transport goes on constantly. Information for analysis is recorded during all races, regardless of whether testing of artificial intelligence or suspension system is carried out. Therefore, the dataset is continuously updated. Drone manufacturers are also constantly collecting information for artificial intelligence training from their cars as they cruise along the streets. However, in their case, it is necessary so as to teach a car to react to all the dangers encountered on the way and to protect against threats from the outside. In the case with SkyWay transport, artificial intelligence has more human goals. Having raised the track to the second level, we have got rid of external threats. Therefore, the artificial intelligence learns to monitor safety inside the transport and calculate the fastest and most convenient route tasks. When unibuses go into mass production and appear on the streets of cities, artificial intelligence will also continue to learn, but this will never be a threat to human safety. Comparing SkyWay transport and drones. Both drones and SkyWay transport systems use several types of sensors, optical cameras and radars. What are their benefits or disadvantages? Optical sensors with well-trained artificial intelligence can easily recognize objects. However, they are still far away from the man's level. After all, the camera sees no more a set of pixels, although it can detect a specific object from a given list in a crowd faster. But the camera measures distance and speed badly. Another drawback is that they are very critical to external conditions, light, rain, fog. Yes, there are various ways to deal with them, but they significantly increase the cost of the surveillance system. The second sensor, which is widely used to detect objects both in stream transport and in most drones, is radar. It is considered to be all-weather, perfectly measuring the distance to an object, its motion parameters. But because of small volume of classifying features, it almost does not identify detected objects, and it perceives everything as an obstacle. During the test, at the test site, we see a reflection from everything: grass, supports, infrastructure. And if the vehicle thought there are traffic obstacles, it would remain to stay still. To improve the information received from cameras and radars, we have created programs that combine data from optical and location sensors. You could see them in action during the demonstration of Anatoly Yunitskiy doggy. We have taught the artificial intelligence to supplement one information with another, so as to make the best decisions based on those data to ensure safe movement of vehicles. This third type of sensors used by some drones, but not by SkyWay Technologies core, are lidars. A thin laser beam scans the area and gets excellent optical reproduction. At the same time, it defines the motion parameters well. It would seem that everything is fine except for some but, because of which we don't use lidars for stream transport. First, it is a high cost. Secondly, a lidar is a mechanical device that has the ability to break. Third, it's an optical device. Therefore, the rain, fog, when the laser beam is dispersed, it sees a wall. In our opinion, it is better to use lidar in California, taking into account that we are orienting on the diverse market and testing transport in Belarus, where rains and fogs are a natural practice. The use of lidars is impractical for us. Almost Skynet. As a rule, each unmanned vehicle is considered as an independent unit. It is self-sufficient with certain parameters and preset information, such as a map of an area. And the movement of such units is chaotic, which in its turn leads to low throughput capacity. In SkyWay, each element of the infrastructure is also endowed with intelligence and quick wits. Plus, there is an also central intelligent control system. It controls the entire transport complex in accordance with the post tasks. It monitors the speed and safety of movement, combines traffic flows, and responds to the wishes of each individual. This system calculates the most convenient and optimal route tasks with a constant updating of incoming data. Another difference between SkyWay intelligence system and unmanned vehicles is the ability to respond quickly to emergencies. failure of any vehicle results in an instant recalculation of the route assignment for the rest of the pods linked with this route, and also in acceptance of measures needed to solve the current situation, evacuation, transportation, etc. That is the difference of our system from competitors' systems in the global traffic flow control without compromising the individuality of each separate vehicle. What do vehicles say? However, communication between vehicles is not limited by a centralized one. After all, the failure of one of its elements could lead to a collapse. Therefore, each vehicle communicates with all elements of the transport infrastructure. Let's assume the impossible that the system ceases to function. Each individual pod knows its tasks, communicates with other pods that are nearby, and relays information about the environment. Therefore, all vehicles can continue running along the route and respond to any changes regardless of system operation. Intelligent control system in action. Development of the technology of vehicle evacuation is an example of how vehicles executed a task from a system, but they also communicated directly during the docking. Doggy is another specific example of work that reveals the capabilities of our systems. The movement of vehicles in a virtual coupling. From the safety point of view, the distance between the vehicles should depend on the braking distance, which is necessary to stop the second one when the first stops. At the same time, it's desirable that it would be as much as possible. On the other hand, to increase passenger traffic, it is necessary to reduce this distance. How can a balance be found? As regards the virtual coupling, we are not the pioneers of this research. The work was carried out by our other competitors. However, we have applied the modernized concept. The first vehicle is the leading one, it performs its route task. The rest ones control the change, their movement parameters, distance, interval, time to the model in front. Why do we need virtual coupling? For example, there is a task to service goods and passengers to the route Minsk-Moscow as quickly as possible. To solve it, we need to maintain a minimal interval between modules, and we will manage to achieve this only through a virtual coupling. The task from system is to make a virtual coupling depending on the existing traffic schedules and individual needs of passengers. The head of Intelligent System Administration of SkyWay Technologies, Evgeny Rodchenkov, appeared in the office. He gets interested in the topic conversation and compliments Yuri Adamovich. By the way, in terms of commercial benefits, a virtual coupling will reduce energy consumption, increase passenger traffic, and correspondingly profit. It will help to reduce the load when driving in a stream, as it works in case of trucks, to reduce the energy consumption and increase passenger traffic. Yuri Adamovich continues to explain the technical side of the issue. Calling in Universe a doggy, Anatoly Eduardovich has not only demonstrated adaptive following after leading, then it's needed to implement the virtual coupling. He also showed the execution of some commands quite unusual for the system: escape, pursuit. You see, when Mr. Yunitskiy said that the problem solved by our company is very serious, he did not boast and palter at all. We are indeed in the lead of this issue. What does Unibus see? Returning to the issues of technical vision, let me remind you how Anatoly Yunitskiy said at the point of the demonstration. The system sees a lot of unnecessary objects and interferences, because unlike smooth upshout, he worked over imperfect surface. And the fact that the system developed has learned to select the necessary objects and process the necessary information at the level of surface distortions speaks of tremendous success. If there were other people in the way of Unibus during the test, it would work them out on the principle of the greatest potential threat. calculating the intersection of them based on the parameters of movement of both the vehicle and potentially dangerous objects. After all, the nearest can move away and standing in the distance to approach. Intelligent system against vandalism. Our technical vision system already recognizes a weapon inside and outside the vehicle, sends a signal potentially dangerous situation detected to the dispatcher. It's who must to take further action. After all, man still plays the most important role because the cost of failure will be quite high. If, say, a person appears in a cabin not with a toy gun but with a real one. And we will allow the artificial intelligence to choose what to do. However, it's not easy to recognize acts of vandalism and potentially dangerous situations, such as an aggressive behavior. Artificial intelligence will have to learn to distinguish a simple slap on the shoulder from the blow or greeting gesture from a threat. But we are using huge databases of datasets that vehicles could be finally able to do it. Evgeny Rodchenkov adds, by the way, there is a film in which not a person teaches a robot, but vice versa. It's called I'm a Mother. Its moral is how the decision is chosen, why in this way, and who is still smarter, a man or a robot. Why won't robots conquer with the world soon? Man flights into space, undertaken in spite of all dangers. The decision to sacrifice himself during the emergency in favor of saving another person, and even the idea of sending a courier for another bottle of wine when it would seem it is time to stop, all these are irrational decisions. Only a man is capable to do that. And it is not known how long will it take to teach a machine to do it, and whether it will work at all. Therefore, it's too early to fear the robot rebellion. After all, they resemble small children so far, and we are very proud of ours in SkyWay.